what type of bond is present in the molecular compound, and then they give us PCl3. Okay, so we got phosphorus, trichloride, and maybe I'll make that this big. We got P, we got chlorine, and we got 3 of them. Okay. And we just want to find out what the bond is. Is it metallic? Is it nonpolar covalent? Is it ionic or polar covalent? Well, this first comes from knowing what types of elements you have. And with types of bonds, usually you can do it the electronegativity method. So let's head on over to the periodic table. We'll find out what phosphorus and chlorine is, whether it's a metal or a nonmetal, and then we'll pick out the electronegativity values. So let's head on over. Here we go, a beautiful electronegativity periodic table for you that I've made. If you notice, let's just pick out our elements, right? Here's our phosphorus, and here's our chlorine. So they're very close to each other. They're both orange, and tell me, what does orange stand for? Are orange elements metals, nonmetals, or metalloids? Yeah, you got it. They're nonmetals. So we have 2 nonmetals. That's going to help us out tremendously. But also, we're going to take a look at the electronegativity values. Now, if your teacher or professor doesn't, not going to give you a periodic table with electronegativities, there's other ways to do this. You could do the electronegativity trend if you want. But I'm just going to use the numbers. We have 2.1 and 3.0. So let's go back to the problem and use those. Okay, so we said that phosphorus was a nonmetal. And we also said that chlorine was also a nonmetal. So we could start canceling some stuff out as well. Now, before I forget, I'm just going to say that the electronegativity for phosphorus was 2.1 and the electronegativity for chlorine was 3.0. Okay. Now, since we're only dealing with nonmetals, we can't have a bond that has to do with anything with metals, because we have none. So, for example, a metallic bond, this is just a metal. So it would just be, copper, or just iron, or just, lithium, or some type of metal. So this can't be it. And ionic generally is for metals and nonmetals. So this one is out as well. So now now we're down to nonpolar covalent and polar covalent. Covalent means that you do have 2 nonmetals, which is what we have. But now we just got to find out whether it's polar or nonpolar. Now, if you don't have electronegativity values, you could always go by the mnemonic SNAP. Snap it out. If the bond contains symmetrical elements, aka the same, then your bond would be classified as nonpolar. So these guys go together. But if your bond contains asymmetrical elements, which are the different ones, then your bond would be classified as a polar bond. Now, I don't really need to specifically know how to draw out the correct Lewis structure here. All we have to do is just know who the bond is with. And I know that I got a phosphorus and I have a chlorine, so I know the bond is going to be between the phosphorus and the chlorine. So, P and Cl. And according to SNAP, these 2 elements are different. They're not the same. They're not like H and H, right? That would be totally symmetrical. That would be nonpolar. So in this case, since we have different elements, we can go by SNAP. Different, asymmetrical, goes with polar. So right off the bat, we do know that our answer is going to be a polar covalent bond. But now I just want to show you with these electronegativity values as well. If you want to do it the electronegativity way, you would take those values, which are just kind of like ratio values. They talk about who's more greedy with the electrons in the bond. And all you do is you take the bigger electronegativity value and you subtract it by the other one. So I have a 3.0 and 2.1. 3.0 minus 2.1 is 0.9. And if we want to do it the electronegativity way, we have to memorize the values. If you have a polar covalent bond, the electronegativity difference would be between 0.4 all the way up to 1.8. Nonpolar covalent would be from basically 0 all the way up until 0.4. Since this is 0.9, we are right in the middle of 0.4 and, 1.8. So that's another way of finding it out. So you could always find out the correct answers many different ways in chemistry. That's the beauty of chemistry. All right? So hopefully this helped. Let me know what you think. Love to talk to you guys. And how's your day going? I hope it's going well. All right? Mine's going well. I'm doing problems. Sitting here doing problems for you guys. I love it. Love hanging out. And, oh yeah, if you want more practice problems, my brother and I, we have a website. You could head on over to glazersguide.com. The link is in the description below. And also at the end of the video, if you want to click it, it'll be tons of practice problems just like this one. And, it'll help you ace those tests and quizzes, all right? So for more practice and for more fun, head on over to glazersguide.com. Ooh, yeah. And here comes the outro music. I hope you like it. And I'll talk to you soon, okay? All right, bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.